Hello. We are going to go ahead and start section 1.4, which is kind of a combination of the reciprocal identities, coming up with some Pythagorean identities, and then solving using those identities to solve for our trig function values. Okay, so we talked a little bit about the reciprocal identities in the last section. Sine's reciprocal is cosecant, and cosecant's reciprocal is sine. So we can actually write sine theta as 1 over cosecant theta, right? And we can write cosecant theta as 1 over sine theta. Now, remember, we have to have the theta in there, okay? So I'm just going to put a little note over here. Do not drop the theta, right? Because if you go from sine theta to just sine, right, it's a sin, right? So you have to have the angle in there, otherwise the SIN doesn't mean anything, okay? So this is true. Each trig function has a reciprocal value. So if you happen to know what cosine is, you should be able to figure out what secant is by just doing the reciprocal. So here cosine and secant are reciprocal, so we can write cosine theta as 1 over secant theta, and secant theta we can write as 1 over cosine theta. And the same thing is true with tangent theta and cotangent theta. Tangent can be written as 1 over cotangent theta, and cotangent theta can be written as 1 over tangent theta. Now, this is something you are absolutely going to need to be aware of, okay? So if you're the kind of person who likes to make cheat sheets or note cards or formula sheets to help you get ready for a test, these reciprocal identities are something that you for sure are going to have to know, okay? Because if I give you a value and I say secant theta equals 2/3, you should be able to tell me that cosine theta equals 3/2, right? Without even thinking about it. You need to know which one goes with which, okay? So it's a good thing to highlight here. So let's look at a few problems similar to that. If we look at the example down here, it says find each of the following values. If tangent theta equals 1/4, then cotangent theta equals what? Well, we know that cotangent theta is 1 over tangent theta, right? Or in other words, 1 over 1/4, right? And 1 over 1/4 means we just flip it, right? Or you can think of this as a division, and we're doing 1 divided by 1/4, and we flip and multiply. Either way, we end up with 4. Okay? If I lose you on anything, please let me know. Send me a text, whatever. Let's get it cleared up, okay? Let's look at the next one. Here it says if cosine theta is -2 over the square root of 20, then secant theta equals what? Well, we know that secant theta is the reciprocal. So instead of writing it all out like I did here, I'm going to go ahead and just flip this. So I end up with, now I will say this, in my math lab, it does not like negatives to be on the bottom of the fraction ever. So if you are given a negative, like in this situation, I would just either leave it on top or write it out front. Okay? I'm going to go ahead and just write it out front and then flip these. So I get negative square root of 20 over 2. And then we definitely want to see if this is something we can simplify, right? The square root of 20 actually simplifies because 20 is 4 times 5, and 4 is a perfect square. So we can bring that out of the radical, right? The square root of 4 is 2. And underneath the radical, we would be left with that 5. And on bottom, we have 2. And now we can actually go ahead and just reduce our 2's, right? Because the 2 and the square root of 5 are written side by side, so that implies multiplication. So we can go ahead and reduce. So we end up with negative square root of 5 as our value for secant theta. Okay? All right. Now, the other thing I want to review is something we did at the end, I believe, of the last section, which was talking about the signs of trig functions. This is going to be super important for us This is something that we should be able to think through. So I'm going to put a little star by this one too. Oh, that doesn't look like a star at all. Let's pretend that that looks like a star. Okay. This is something that's super important because we will use our knowledge of what the sign of a trig function is when we're going through our solving process. Okay, so I want to go ahead and just write out what our sine theta, cosine theta, tangent theta values are in each of the quadrants. Okay, so I'm going to go ahead and write sine theta, cosine theta, tangent theta, sine theta, cosine theta, tangent theta, sine theta, cosine theta, tangent theta. Okay, so let's think about it. So remember, sines, we get the sine value we get by doing y over r, right? And r is always positive. So with sine, we really only need to know about the y value. Cosine, remember, is x over r. So since r is always positive, we really only need to know about the x sine, right? And then for tangent, tangent is y over x. So we need to know both the sine of y and x and think about when we divide those, what kind of sign is that going to produce, right? So if we look in quadrant 1, if I draw any angle out here in quadrant 1, right, we're going to have both x's and y's are positive, right? In quadrant 1, x's and y's are positive. So if my y's are positive, that tells me that my sine values are going to be positive. If x's are positive, that tells me that my cosine value is going to be positive. And if my x and y are positive, then when I do a positive divided by a positive to calculate my tangent value, that's also going to be positive. Okay? Does that make sense? So I want you to think about each of these quadrants. I'm going to have you pause the video, and I just want you to fill in with the signs of the trig function. Are they going to be positive or negative based on what the x and y's are within that quadrant? Okay, so go ahead and pause it, give it a go, and then when you're ready, unpause it, and we'll go over it. Okay? Okay, let's see how you did. So this is quadrant 1 that we already that I already did for you. When we move to quadrant 2, notice our x's become negative, right? Over here, this is the negative side of x, right? And our y's are still positive because they're above the x-axis. So if my y's are positive, that means my sine is positive. My x's are negative, which means that my cosine is negative. And then my ratio of sine to cosine, or y to x, a positive and a negative makes this negative. Okay? Then we look in quadrant 3. Here they're both negative, so that means both my sine and my cosine are going to be negative. But when I calculate tangent by doing y over x, a negative over a negative is going to end up positive. Okay? And then in our last quadrant, 4 down here, we have positive x's, negative y's. So negative y's means negative sines. Positive x's means positive cosines. And tangent is going to be a negative over a positive, which is still negative. Okay? So this is going to come into play a lot when we start solving, because when we solve, we might get something like plus or minus, and we have to determine, do we take the positive answer, or do we take the negative answer? So all we have to think about is, well, what quadrant is this angle in? And then say, oh, okay, well, the cosine value in that quadrant should be negative, or whatever the case may be. Okay? All right, so let's do a little bit more with this idea of the signs of the trig function values. So at the top of page 2, it says, find the signs of the trig functions for each of the following angles. And I'm actually going to just create a little chart, because that might be a little bit easier than writing it out for all 3 of them. So I'm going to go ahead and just list all 3 angles. So we have 54 degrees, we have 260 degrees, and we have negative 60 degrees. And for each of them, we just want to figure out what the sign of their trig function value is, okay? Only the signs, not the actual values. So we want to know what sine theta is, we want to know what cosine theta is, and we want to know what tangent theta is. And notice, when I'm doing these, I'm not doing cosecant, secant, and tangent, right? Because since those are reciprocals, whatever the sine of sine is going to be the sine of cosecant. Whatever the sine of cosine is, that's going to be the sine of secant, right? Whatever the sine of tangent is, that's going to be the sine of cotangent. So I don't have to do all the reciprocal identities when I'm determining the sines. Okay. All right, so I'm going to do the first one, and then I want y'all to try the next two. So to give me an idea about this angle, I want to go ahead and graph it. So 54 degrees, if I were to draw it, it's going to be somewhere between 0 degrees and 90 degrees, right? Which means it's going to fall over here in quadrant 1. Okay, so 54 degrees looks something like that. So if I am in quadrant 1, my y's in quadrant 1 are positive, right? Because they're above the x-axis. So if my y's are positive, that means my sine value is positive. Notice in quadrant 1, my x's are also positive, right? Because they're to the right of the y-axis. So if my x's are positive, that means my cosine is positive. And then to figure out my tangent, I just have to do the ratio of these two, right? Positive over positive gives me positive. Okay, so I want you all to do the same thing. I want you to do a quick little sketch of 260 and negative 60. Okay, think about how to draw a negative angle. And then once you do that, fill in the rest of this chart. Okay, and then unpause the video and we'll go over it. Okay, so when we look at 260, that's going to be over here between 180 degrees and 270 degrees. So that's falling way over here in quadrant 3. Quadrant 3 has negative y's because we're below the x-axis, so that's going to give me a negative sign. It also has negative x's, right? Because we're to the left of the y-axis. So negative x's gives us a negative cosine, and then a negative y over a negative x gives us a positive tangent. Okay? And then our last one was a little bit tricky because it said to do negative 60 degrees. So that means we're starting at 0 and going clockwise, right? Negative angles go clockwise. So we're going down 60 degrees, which is going to be between 0 and negative 90. So it lands in quadrant 4. Quadrant 4 has negative y values. So negative y's give us negative signs. We're still in the positive x, right? Because we're to the right side of the y-axis. That's going to give us a positive cosine. And then the ratio of a negative y to a positive x gives us a negative tangent. Okay? All right. So now let's look at some problem types that we're going to use to solve to find missing values. Okay? So this first one is finding the correct quadrant. Okay? So it says find the quadrant of the terminal side of angle theta that satisfies the following conditions. So if I look at part A, it says my tangent theta has to be greater than 0, right? So that's positive. And my cosecant theta has to be less than 0, which is negative. Okay? So let's think about that. I'm going to come down here and just draw my quadrants. Okay? So tangent, the places where I get a positive tangent is when my y over my x becomes positive. And the only time that my y and my x create a positive is if they are both positive or if they are both negative, right? Because a positive over a positive gives me a positive and negative over a negative gives me a positive. So I have to figure out the quadrants where that happens. So when x's and y's are both positive, that happens in quadrant 1. So I know in this quadrant, my tangent is positive, right? I also know I get a positive tangent when I have a negative x and a negative y. So that happens down here in quadrant 3. So down here, I know that my tangent is going to be greater than 0. Okay, cat's going crazy over there. All right, and then our second stipulation is that cosecant has to be negative, right? Now remember, cosecant theta is the reciprocal of sine theta. So whatever the sine of sine is, it's the same as the sine of cosecant. So instead of worrying about this being cosecant, I'm going to relate it to sine. And sine has to do with y values, right? So I basically want to know, where are my y values going to be less than 0 or negative? So this is my y-axis, right? So negative y's happen down here in quadrant 3 and over here in quadrant 4. So I'm going to write that last stipulation there, okay? So cosecant, oh, I did the ultimate sin. I just realized I didn't write a theta after this tangent. Let me write this tangent theta. Sorry. So cosecant theta is less than 0, and it's also cosecant theta is less than 0 here, okay? So what we're doing on part A is we're trying to determine where are both of these stipulations satisfied, right? And you can see that the only place where these two stipulations are satisfied is down here in quadrant 3. So my answer for part A would be quadrant 3. Okay? All right, so let's look at the second one. Actually, I'm going to let you pause the video, and I want you to try to work out the second one, okay? It wants to know where sine theta is greater than 0 and where cosecant theta is greater than 0. So go ahead and pause the video and try and work that out, and then when you're ready, unpause it and we'll go over it. Okay, so let's look at the second one. Sine and cosine are actually related, right? So wherever sine is positive, that's also going to be where cosine is, or not cosine, cosecant is positive, right? So sine, we know, has to deal with the y value, and y values are positive in quadrant 1 and 2. And since sine and cosecant are inverses, that is also where cosecant is going to be positive, right? So on this one, if we're asking where are these two stipulations true for both, right, then we would have two answers. This is true for quadrant 1, and it's also true for quadrant 2, okay? Not always will you get more than one answer, but on this one, obviously, we did because it's true for both. All right, let's look at some other ones, solving, and then we'll move on. Okay, this says, given theta is in quadrant 3, okay, and tangent is 8/5, find the sine and the cosine, okay? So I'm going to use the idea that we know it's in quadrant 3. So if I wanted to draw this, it's going to be down here in quadrant 3 somewhere, right? And I can actually use this tangent value because we know that tangent is our y over our x. Okay? Now let's think about this though. Over here in quadrant 3, this is where we have negative x's and this is where we have negative y's. So in order to have gotten a positive 8/5 for our tangent, that means we must have gone out to -8 and down to -5, right? Both of these had to have been negative so that when we put them together as a ratio, right, or as a fraction, we get a positive value. So I'm going to go ahead and draw this. 1, 2, 3, 4, 5, 6, 7, 8. So this is -8. 1, 2, 3, 4, 5. So this is -5. Can't really tell if that's straight, but I'm going to go ahead and draw our terminal side. Okay, so this is our angle, theta. Okay, so I filled in everything we know about it. I know that my x value had to have been -8. I know that my y value would have had to have been -5, right? Because if I would have kept them positive, if I would have done x is positive 8 and y is positive 5, that would have put me up here in quadrant 1, right? And it told me it's in quadrant 3. So now what I want to do is I need to figure out what my sine and cosine values are, right? Well, in order to find sine, I need to know my y value and I need to know my r value, right? In order to find my cosine value, I need to know my x value and my r value. So I do know my x and my y's, but I don't know that r value yet. So I'm going to go ahead and just use the Pythagorean theorem, right? Turn this into a triangle, and I should be able to figure out this r value. So remember, r we can find by doing the square root, and then we square our x and our y's and add them together, right? So x squared would be negative 8 squared plus our y value, so negative 5 squared. So this tells me that r is equal to 64 plus 25 under my radical, which gives me what? The square root of 89. And I don't think that simplifies, because 89 would be what? 17, 8. It's not even. Yeah, there's nothing we can do to simplify that. But now that I have my r value, and I know my x value and my y value, I should be able to find my sine and my cosine. So in order to find my sine value, I do my y, which I know is negative 5, over my r, which is the square root of 89. And then remember, my math lab always has us rationalize the denominator, which means I need to get rid of the radical in the denominator. So I'm going to go ahead and just multiply by the square root of 89 on top and bottom. And that's going to give me negative 5 times the square root of 89 all over 89. And then if I could reduce my 5 and my 89, I would. In this case, it doesn't reduce, so I'm just going to leave it like that. Okay. Then we do the same thing for cosine. Cosine is x over r. My x value is negative 8. My r value is the square root of 89. And then again, we can't leave it like that. We have to rationalize our denominator. So again, we're going to multiply by the square root of 89 over the square root of 89. And we end up with negative 8 square root of 89 all over 89. And again, we can't reduce 8 and 89. And the radical doesn't simplify, so we're just going to leave it like this. Okay? So see how we used the knowledge of what quadrant it's in to figure out the signs of the x's and the y's, and to figure out the signs of the cosine and sine values, right? Because notice, just to double check, since we're down here in quadrant 3, we know that down here in quadrant 3, our y's are negative and our x's are negative. So that means we should end up with a negative sine value, which we did, and we should end up with a negative cosine value, which we did. Okay? So a good way to check yourself. All right, so now let's look at some Pythagorean identities. So what's good about these identities is if you ever forget them, they can all be derived from the Pythagorean identity. Okay, so I'm going to start, remember when we had a triangle that we drew from an angle, right? Oops, let me move my triangle down so you can see it. Remember we had an x and we had a y. And actually, whenever you learned the Pythagorean theorem, you probably had like an A, B, and a C, right? But here when we're dealing with angles, we call this side our R, right? So the Pythagorean identity, or theorem, says that x squared plus y squared equals r squared, right? So what I'm hoping to do is, from this identity, I'm hoping to be able to get this identity. So if I'm looking at what I have and what I want to get to, the first thing I see is that I have a 1 over here. I like the idea of working towards a 1 because I can easily make this side of the equation equal 1 if I just divide by r squared. So I'm going to go ahead and divide each term by r squared. So I have x squared divided by r squared. I have y squared divided by r squared. And I have r squared divided by r squared. Okay, so this is going to cancel and give me the 1 that I need, right? These other two, when I have the top of a fraction squared and the bottom of a fraction squared, I can actually write that as the whole fraction squared, right? Oops, I didn't mean to write a y. I meant to leave that as an r. Okay? And then I can do it for the next term as well. This is the same thing as y over r squared equals 1. Okay? And then notice these are actually our trig functions, our trig function values, right? X over r is cosine. So this is the same thing as cosine theta squared. And y over r is the same thing as sine. Sine theta squared equals 1. And then, so that we don't have to write a ton of parentheses, the way that we write squared values when we're dealing with trig functions is instead of putting parentheses and putting the square on the outside, they just write the square after the cosine, after the trig function. So we would write this as cosine squared theta plus sine squared theta equals 1. And now you can see that we ended up with what we were trying to prove. Okay? So what's neat about this is we were able to derive this from the Pythagorean theorem because we chose to divide off the r squared, right? But we actually can come up with 3 different identities because instead of dividing off the r squared, I could have divided off the x squared, or I could have divided off the y squared. So in each case, it gives us a new identity. And I'm not going to go through all of them, but I am going to write them down here. Or highlight them. These are definitely identities that we are going to want to have memorized. So again, if you're keeping a note card or anything to help you keep your notes or your thoughts or your study habits straight, all 3 of these are good ones to add. So this is the one, this first one, sine squared plus cosine squared equals 1. That's the one we just found above, okay? And we got this one by dividing by r squared, right? That's how we got this 1 on the other side. So I want to just kind of think through these other ones. I don't know if I can get all this to fit on my screen at once, maybe. Yeah, okay, so I want to look at my Pythagorean theorem and look at this one. So if this one starts with a 1, that means that I had to have divided off my x squared. So if I divide by x squared here, it's going to give me the 1. If I divide by x here, y over x is going to end up being tangent, right? And then over here, if I divide by x, r over x, well, that's the reciprocal of cosine, which ends up being secant, right? So again, I'm not going to go through the whole proof, but that's how we're getting these. This one, I would get this identity, solving it the same way, but instead of dividing off the r squared, we would get this one by dividing by x squared, okay? And then similarly, 1 plus cotangent squared theta equals cosecant squared theta, we would get that one by dividing by y squared. Now, although I'm not going through these proofs, these are proofs that I would love to put on a test, okay? So on your own time, you might try these other 2 just to see if you can start from x squared plus y squared equals r squared, divide off the appropriate thing, and end up with the identity shown here, okay? All right, so these are the super important identities that we want to remember. And sometimes it's hard to remember identities, right? So I always have kind of like some silly ways to help us remember it. It either helps you or it doesn't, but I'm going to throw them out there and see. So the way that I remembered the sine squared plus cosine squared equals 1 is that I always learned that this was you sin, then you confess, and then you're one with God. Okay? Oh, whoops, sorry, I wrote off the paper. I just keep moving it, don't I? Alright, so sin, confess, then you're one with God. So that's how you remember it. Sin, cosine is our confess, equals you're one with God. Okay? The other one is 1 tan sec. And I was like, how am I going to remember 1 tan sec? I just remember like when a parent gets mad, you may not have cussing parents, and that's wonderful. But if you do, and you're rushing them, usually they'll say, just give me 1 damn second, right? 1 damn second. Well, we're not going to say damn. We're going to say tan. Give me 1 tan second is how we're going to remember this one. Okay? So 1 tan second. Give me 1 tan second, right? All right, and then the last one is 1 cotangent cosecant. And I was like, okay, co this and co that, cotangent cosecant, coco. And I remember when I was a waitress in college, I worked at this place, and this guy came in and his English was very broken, and he would always want to order hot chocolate. And whenever he would sit down, I would just look at him and he'd say, 1 cocos, 1 cocos. And so that kind of made me think of this as 1 cotangent cosecant. So the last one is 1 cocos. He wants 1 cocos, please. Okay, now, remembering coco, you do have to remember cotangent comes first and then cosecant. Okay, so you can think of this one. Make sure you don't get that confused with cosine. Okay, 1 cotangent cosecant. And again, this is just to kind of help you remember these 3 identities. You sin, you confess, you're one with God. 1 tan second, and 1 cocos. So hopefully that will help you as you're studying. Okay. All right. So quotient identities. These are identities that you may have already put together, or you may have already seen for those of you who've taken a little bit higher math class. But I'm going to go ahead and just prove why these identities, or that these identities work. Okay. So we already know that tangent theta we get by doing y over x, right? So what I want to show you is that I want to show you can also get tangent theta by simply doing sine over cosine, okay? So I'm going to go ahead and write, if I wanted to figure out sine theta over cosine theta, I want to show that this is actually equal to tangent. So let's go back to definitions. Sine we determine by doing y over r, right? And then cosine we get by doing x over r, right? And when we have a fraction divided by a fraction, we keep, change, flip, right? So this is the same thing as saying y over r times r over x, right? If we flip the bottom and multiply, and then notice our r's cancel, and we end up with y over x. So if sine theta over cosine theta equals y over x, and tangent theta equals y over x, then what we can deduce is that tangent theta is equal to sine theta over cosine theta. Okay? And this is what we call a quotient identity, because we're using the quotient of 2 trig functions to define another one. Okay, so this is also an identity that you're going to need to be aware of. Okay, right? And then the same thing with cotangent. Okay, cotangent, remember, is the reciprocal of tangent. So instead of y over x, this would be x over y, right? And so what I'm hoping to prove this one equals, instead of sine over cosine, I want to show that this one is the same as cosine theta over sine theta. And we work it out the exact same way. Cosine is defined as x over r. I sure can't make a video when somebody's crying in the background. And sine theta is equal to y over r. Then again, when we divide fractions, we flip and multiply by the reciprocal of the bottom, right? So x over r times y over, oh, I didn't flip. I said to flip it, and then I did not flip it. R over y, okay? Then my r's cancel, and I end up with x over y. So if cotangent equals x over y, and cosine over sine equals x over y, then that means that cotangent theta is equal to cosine theta over sine theta, right? And we could have proven this a different way. We could have started here and just said, if this is what tangent equals, then cotangent is the reciprocal of that, right? So just flip it. Okay. Okay, doke. So let's look at solving some of these. My dogs are going crazy for some reason. I apologize for that in the background. Hopefully they'll calm it down in a minute. All right, so let's look at some where we are given some information and we need to find the missing values. So here, if we look at this, it says, given that sine theta is equal to negative square root of 2 over 3, and cosine theta is greater than 0, find these values. Okay, so I want to figure out what quadrant this is in, because right away I see some signs, I see this, that's going to be important. So I'm going to go ahead and draw just a little quadrant thing and try to figure out where it's at. Okay, now this says sine is a negative. So if sine is negative, that's got to happen down here or down here, right? Because sine has to deal with our y value, and y values are negative below the x-axis, okay? Now this one says that cosine has to be greater than 0. Cosine has to deal with our x value, so where are our x's greater than 0? Well, x's are greater than 0 on the right side of the y, right? So that happens here and here. So in order for both of these to be true, then that means we have to be down here, right? So we're in quadrant 3. Okay, so that's going to help us out. That's good to know. So now whenever we get our answers, we can make sure that they have the correct signs for quadrant 3. Okay? All right, so let's see how we can solve this. It says, given that sine is negative square root of 2 over 3, we want to find cosine. So we need an identity that uses sine and cosine. And if we look back at the previous page, the only identities that had sine and cosine was tangent and cotangent, those quotient identities we just figured out, but we're not given tangent or cotangent values. That doesn't help. Or we can use our new Pythagorean identity that if we sin, confess, we're one with God, right? So I'm going to go ahead and say that sine squared theta plus cosine squared theta equals 1. And I'm going to fill in what I know. I know the sine is negative square root of 2 over 3. So negative square root of 2 over 3 squared plus cosine squared theta equals 1. So I'm going to go ahead and square, and you know what I'm going to do for the sake of room? I'm going to move part B over here. Theta. That way I can just work straight down. Okay? All right, so when I square this, if I square a negative, it's going to become positive, right? When I square a square root, that cancels out. Square root of 2 times square root of 2 is just 2. When I square the 3 on bottom, that gives me 9. Plus cosine squared theta equals 1. Now I need to move my 2/9 to the other side. So I'm going to subtract 2/9. Right. So I end up with cosine squared theta is equal to 1 minus 2/9, right? Well, 1 is the same as 9/9, right? 9/9 minus 2/9 gives me 7/9. 7/9, right? And then this is squared. And remember, we're looking for cosine theta, not cosine squared theta. So to get the square off, we're going to square root both sides. And remember, when we square root both sides, we have to use plus or minus. Okay. So that means we're going to end up with plus or minus the square root of 7 over 3, because I can simplify the bottom here. Okay. All right, so let's go back up here and think about this. I need to know, do I take the positive answer or do I take the negative answer? So when I look, I know that this is in quadrant 3, and in quadrant 3, my cosine value is greater than 0, which means we want the positive, right? I'm just going to say, I'm not going to say anything because I have it written up here. We want the positive. So this tells us that cosine theta is equal to the square root of 7 over 3. Right, positive. Okay. All right, so now we know our cosine value, and they gave us our sine value, so that should make it very easy to figure out part B, which is asking for our tangent theta, right? Remember, our Pythagorean identities was you sin, you confess you're one with God. That's sine and cosine. That doesn't give us tangent. And then we have 1 tan second, right? So we could use that one because we need tangent, and well, no, because we don't have our secant, but we could use the reciprocal of cosine, right? But I think the easiest one to use is our identity that says that tangent theta is the same thing as sine theta over cosine theta, because now we know both of these, right? Sine theta was given to us, negative square root of 2 over 3. And cosine theta we just figured out to be the square root of 7 over 3. So now all we have to do is flip and multiply by the reciprocal of the bottom, right? So tangent theta is equal to negative square root of 2 over 3 times 3 over square root of 7. We can reduce our 3's, which gives us negative square root of 2 over negative square root of 7. And then again, my math lab wants our solutions not to have radicals in the denominator, right? So we're going to go ahead and rationalize the denominator by multiplying by the square root of 7 over the square root of 7, which tells us that the tangent is equal to negative. Now, when we multiply a square root by a square root, we can multiply what's underneath. So this gives me negative square root of 14 all over square root of 7 times square root of 7 becomes just 7. And I can't reduce the 7 and the 14 because one's under the radical and one's not. So we just leave it like this. Okay? We kind of okay with how we're using these properties? Okay. So I want y'all to go ahead and pause the video and just give it a go. See if you can figure out for the next two problems, part A and part B, which identities to use to solve for this. So in this one, it's giving you cosine, and you're looking for cotangent. So I would flip back over to the other page and see if you have an identity that involves cosine and cotangent. If not, maybe look for one that has tangent and secant, right? So I want you to pause the video, try A and B. If you get stuck or you don't know how to get started, or you get finished and you're ready to check yourself, go ahead and unpause it and we'll go over them, okay? All right, so let's think about these. Now, there are a lot of different ways to solve this. So if you did not use the method I'm fixing to go over, it does not mean you're going to get the wrong answer, right? So cosine and cotangent, we have the identity of 1 tan second, right? And we could use tan and cotangent's relationship. We could use secant and cosecant or cosine's relationship. So if you use that one, that is one way to find cotangent. I am actually going to use the idea that cosine and sine are related to tangent to figure out what the cotangent is. Okay? Again, there's no wrong way, but what I'm seeing is I already know cosine, right? I already know cosine. So what I'd really like to know is sine. Because if I know cosine and I know sine, then I could use the ratio to figure out cotangent. Okay, so I'm going to just ignore cotangent for a minute. And I'm going to say that I know that sine squared theta plus cosine squared theta equals 1, right? And I'm going to fill in the value that's given. So sine squared theta plus my cosine value, which is negative 7 over 25 squared, equals 1. So I'm going to go ahead and square this value, and that way I can move it over here and combine it with a 1. So I get sine squared theta plus, when I square this, I'm going to get 49 over 625, which is a pretty ugly fraction, right? And then I want to subtract that to the other side. So if I move it over here, I'm going to be subtracting 49 over 625, right? So I end up with sine squared theta is equal to, now again, this 1 I could write as any number over itself. So I could think of that as 625 over 625. So if I do 625 over 625 minus 49 over 625, that's going to leave me with 576 over 625. Okay? And then I don't want sine squared, right? I just want regular sine. So I need to take the square root. And when I do that, I have to do plus or minus. And luckily for me, these are both perfect squares, right? So this tells me that sine theta is either a positive or a negative 24/25. So let's figure out which one I need. Okay, it says it's in quadrant 2. So if it's in quadrant 2, that's over here, right? And in quadrant 2, my sine value, which is related to my y's, right? In quadrant 2, y's are positive. So I want the positive. Okay? All right, so now that I know what sine theta is, and I know what cosine theta is, now I can go ahead and figure out what cotangent theta is. Okay? So I'm going to go ahead, I'm going to move this down in a minute, so I'm just going to ignore it. So I'm going to go ahead and say cotangent theta. Now, tangent is sine over cosine, right? So cotangent is going to be the reciprocal of that. So that's going to be cosine theta over sine theta. Cosine theta was given to us. It's negative 7 over 25. And sine theta, we just figured out, is a positive 24 over 25. And then again, we can flip and multiply by the reciprocal of the bottom. So negative 7/25 times 25 over 24. My 25's cancel, and I'm left with negative 7 over 24. So that is my cotangent value. Okay, let's look this up. So I'm going to go ahead and move part B down here, which is asking us to find the cosecant of theta. Okay. So let's think about this. Cosecant is what? Cosecant is one of the reciprocal identities, right? And it's the reciprocal of sine theta, right? This is the same thing as 1 over sine theta. So sine theta is actually something we found, right? That was the first thing we found. So we know that sine is positive 24 over 25. So we can say this is the same as 1 over 24 over 25. And then all we have to do is flip and multiply, right? 1 times 25/24 is just 25/24. Right? That one's pretty easy once we have it down. So again, there are a lot of different ways to solve these based on which identities you use. So if you use something different than me, you should have still got the same answer for cotangent. But if you did use one of those other identities, you probably had to do a little bit more work when you got to solving for cosecant theta. Okay? All right, there's one more little thing I want to go over, and that's talking about the range of trig functions. Like, what possible answers could we have? We've talked about, you know, depending on which quadrant they're in, if they're positive or negative, but we haven't talked about how big or small the trig function values could actually be. Okay, so I want to do that on the next page. And then once we have that information, then we can check to see if an answer seems appropriate or not. Okay. All right, so this is talking about the range of trig function values with the possible output of these values. Okay, so we're going to look at sine first. Sine is y over r, right? So let's just put it in standard form. We would have our terminal side, right, with our angle theta here. And maybe this goes through some point xy, right? And we can draw down our little triangle. Okay. So what we know is this is our x side, this is our y side, this is our r side. Now, it's true for any triangle that this hypotenuse length is the longest length. If we're in quadrant 1, we agree that y is greater than 0, right? That's obviously y is greater than 0 because we had to go out a certain distance on our x and on our y, right? So we know that y is greater than 0. We also know that y is less than r, right? This length y has to be smaller than the hypotenuse r, right? These are just known facts, okay? So what if I took r, which is always positive, right? This distance is always positive, and I divided both sides by r. If I divide both sides by r, I end up with y over r is less than 1, right? Because I would get r over r on this side, which is 1. And then here, that's what we define sine to be, right? So y over r is sine. So this tells us that sine theta has to be less than 1, right? Now this is for standard position, right? Let's think about y over here, like if I drew this on down, let's think about y in quadrant 3, right? So y over here, down here in quadrant 3, this would be a negative y, right? Now this negative y is still got to be smaller than this r distance, right? Negative y is smaller than r. So we could do the same thing. We could go ahead and divide both sides by r, which doesn't change the symbol, right? Because r is always positive. So that gives me negative y over r is less than 1. And then I could divide off this negative, right? Now remember, when you divide by a negative and you're dealing with inequalities, that flips the symbol. So if I divide this side by a negative, I would get a positive y over r, and that would flip the symbol and make it greater than negative 1, right? Just dividing both sides by a negative, which flips the symbol. So this says that sine theta is greater than negative 1. So when we think about the range of our sine function could be anything smaller than 1, but greater than negative 1. So we can write that like this. It's greater than negative 1, but smaller than positive 1, right? And we could actually do the same thing with cosine, right? Cosine, we know that x has to be smaller than r, right? X has to be smaller than r. We could still divide off the r. Over here in the negative, x has to be smaller than r, right? If this is x, r is still our longest side. So we could similarly solve, I'm not going to solve all of them, I'm just talking about it, but we could similarly solve the same way for cosine and see that cosine also, all of the cosine function values have to be between negative 1 and 1. Okay? Now, when we get to our reciprocal functions, that gets a little tricky. Okay? So I'm going to go over just the cosecant ones, and then we can kind of say similarly the same thing is true with secant. So if we look at cosecant, I'm going to take these two down here. So looking at cosecant theta, we know that sine theta is less than 1, And we know that sine theta is greater than negative 1. Okay. So for cosecant here, we got this first one, this first sine theta is less than 1 from our standard position, right, up here in quadrant 1. So we know this sine value is positive, right? So I'm going to go ahead and just divide both sides by sine because I'm trying to come up with cosecant. So that's going to give me sine theta divided by sine theta is less than 1 over sine theta. And I don't have to reverse this symbol because remember, since this one came from quadrant 1, I know that my sine value is positive. Okay? So what that gives me is 1 is less than 1 over sine, which is cosecant theta. So this tells me that cosecant theta has to be greater than 1. Right? And similarly with the other side, if I work this one out the same way, saying this came from quadrant 3, which is the negative side of sine, right? And I work it all out, what I'll end up with is negative 1 is greater than cosecant theta. Okay? For the sake of time, I'm not going to go through all the proofs, but I want to make sure that you have this chart available to you. So cosecant, whereas sine was between negative 1 and 1, notice cosecant is on the outside ends. It's either smaller than negative 1 or larger than 1. Okay? So cosecant theta is less than negative 1 or cosecant theta is greater than 1. Okay? And similarly, we can go through the same type of proof with cosine to show that its inverse secant reacts the same way. Secant theta also has to be smaller than negative 1 or larger than 1. So what that's telling me is that all of these first 4 trig functions, right, sine theta, cosecant theta, cosine theta, and secant theta have restrictions, okay? Or they cannot just go unbounded, right? They have range restrictions. But tangent and cotangent, that's a little bit different because remember what tangent is. Tangent is y over x, right? So we can't use this idea that y has to be smaller than x or x has to be smaller than y because y could be anything, right? And x could also be anything. So if we divide any kind of positive or negative number by any other kind of positive or negative number, we're going to get a whole range of different outcomes, right? Which tells me that my tan values, or my tangent values, can go from negative infinity to infinity. Okay? And the same thing is true with my cotangent. I could have any outcome from negative infinity to infinity. Okay? So tangent theta and cotangent theta do not have restrictions, whereas the other ones do. Okay? So now that we know what kind of possible outputs these functions can have, now we can answer problems that ask us if these trig function values are reasonable. Okay? So for instance, looking at this one at the bottom of the page, it says, are these possible or not possible? So part A says cotangent theta is equal to negative 0.999. Okay? Well, if I look up here at my cotangent theta, it says cotangent theta takes on all values from negative infinity to positive infinity. So yes, this one is possible. Okay. If I look at the next one though, the next one is a cosine value, right? And remember, cosine values have to be between negative 1 and 1. So for part B, it says cosine is equal to negative 1.7. That's not going to be possible, right? Because negative 1.7 is over here on that side of negative 1. And we know that cosine values are stuck between -1 and 1. So that means this one is not possible. Okay, now in your homework on My Math Lab, if it just gives you one like this and it's multiple choice, it says it's possible or not possible, I'm fine with you just clicking the right answer. But if I give you something like this on an exam, I will say, is it possible or not possible, and why? Okay, so if you're given something like this on an exam, I'm expecting you to say not possible because cosine values have to be between -1 and 1. Or I want to see this little compound inequality that shows the values of cosine. Does that make sense? Okay, so there has to be some kind of justification, not just I took a guess and it's either right or wrong. Okay. All right. And then the very last one says, can cosecant be 0? Okay. So again, if you look back at your chart, cosecant, oh, that is not how you spell it. It is not. Oh my gosh. Cosecant theta, that's what I was working towards, has to be less than -1, or it has to be greater than +1, right? So this is asking, can it be 0? Well, that's not possible, because it either has to be smaller than -1, so like -2, -1.999, -1.0795, right? Or things that are bigger than 1. So anything between -1 and 1, it cannot take on those values. So again, here, this is a not possible one. Okay. All right. So that is the end of section 1.4. So you should now be able to do that assignment on My Math Lab. If you have any questions, please let me know. I'm happy to help.